Hello friends, welcome to my channel Manish Chawla Education, and in this video we are going to see Apache Kafka. Apache Kafka is a high throughput fault tolerance message queue, and it was developed by LinkedIn and it got open sourced after that. It handles a billion of daily events and it powers real-time data pipelines for 80% of the 100 Fortune companies. So in this slide we are going to see Kafka core concepts and components. So in terms of Kafka, there are some producer applications over there and there are some consumer applications over there, and there is a logical partitioning over there which is called as topics, and we have brokers, basically these Kafka servers that store the topic partitions. So what happens in general, there will be some producer applications which are publishing the data, publishing the information, or we can say the messages in terms of Kafka. So they will be publishing those messages, those informative messages to the topics, and topics are their logical partitions. And after that we have consumer applications. So these consumer applications will be reading from those topics, and before reading those messages, the consumer have to subscribe those topics. So the consumer will be subscribing that kind of topic over there, and then it will be start reading the messages. Topic is nothing but a logical partition. You can name it by, suppose you are having payment transactions over there, so you can name similar to payments or payment events like that. And suppose you are having the user information like that, so you can have the user data, user info data like that. You can define your topic. But in topics also we have some partitions over there, and these messages will be going into those partitions. So in topics we have partitions over there, and what happens, suppose in a particular topic you have 4 partitions over there, and this message are recognized by offsets basically. So suppose in 4 partitions you have the 10 messages, and in one partition number 1 you have 3 messages, then in 2 3 messages, then in partition number 3 you have 3 messages, and in partition number 4 you have 1 message. So what happens in each partition, like offset will be starting from 1 to n. So in partition 1 we have 3 messages, so the offset will be like 1 2 3, and in partition 4 we have only 1 message, though offset number will be 1 over there. So like that we have a distributed kind of mechanism over there, so that we can distribute our messages into those partitions, and the consumer can read in parallel. So you can see this architecture on screen. So basically there are producers which are producing those messages, and there are 3 partitions in one particular topic, and we have messages like ABCD, AB and B, A. Yeah. So then we have the consumer application in the right side, and we have a consumer group. So we will come again later to this consumer group term, and so these consumer are subscribing to this topic, and they are reading the messages from this partitions over there. And in Kafka there are Kafka brokers over there, which are basically multiple servers from that particular cluster, and these are like used to store the topic partitions over there. And there is a ZooKeeper. So basically ZooKeeper is an external service which are having coordination like mechanism over there, and which ensure the high availability of our topic partitions and our application over there. Okay, what is the producer flow? So producer are nothing but just applications over there. Suppose you are having payments data over there, so there are some machines over there, POS GL, and this mobile phones over there. So these are basically producing some messages to a particular Kafka topic, let's say the payment topic. So this producer are basically writing messages, and these are writing messages to the topic partitions over there, whichever partition is defined over there. So they are writing to topic partitions, and it is basically appending the message chronologically. So basically there is offset number, and by that offset number we are appending those messages to topic partitions. and there is a acknowledgement system over there which ensure the data durability, and for the fault tolerance we have replicated the data, and there is a leader broker which is receiving the writes, and the followers will replicate those data. Then we have consumer flow, how the data is consumed from topic. So we have consumer applications over there, and which will be reading the messages from topics. They have to subscribe the topic, and then they have to extract out the messages. Then we have commit offsets. So basically offsets are committed to Kafka, so that we can track the progress that I have, the consumer will say I have done with this message, and it will commit the offset. Then we have this consumer group which we have seen in architecture. So suppose you are having a payment application over there. Basically some messages are produced, and they are sent to a particular topic over there. So and after that we have a consumer group. So what happens in consumer group, we can have some group of some consumers over there, and what happens, like you want to distribute some load over there. Like suppose you want to have 40% of messages in one particular consumer group, and then 60% in another consumer group, and like you want to filter out some messages on a particular um, event or like that. So what you can do, you can make a consumer group over there, and suppose you want to filter out like let's say you have filtered out 40% of load. So 40% of load will be going into one consumer group. So yeah, multiple consumers are basically reading from the same topic, and there will be some partitions over there. Let's say you have in one particular topic you have 4 partitions. So for maximum parallelism, what can we do, like in consumer group we can have 4 consumers, so which can basically per partition the consumer is reading from there. And suppose one consumer is dead, so let's say we have 3 consumers there, so 3 consumers can read from the 4 partitions over there. That can be happen. But what cannot be happen, like from a one particular partition more than one consumer cannot read, to avoid the data duplication over there. Then we have scalability and fault tolerance. So we can have horizontal scaling in Apache Kafka. Basically we can scale brokers and partitions, and data replication to provide the fault tolerance. So data is replicated across multiple brokers so that we can have fault tolerance feature over there. And then we have a leader follower model, like each partition is having a leader and then follower. And ZooKeeper elects new leaders. Whenever there is a failure, it will elect new leaders automatically. So it is automatic failover, and fault tolerance is provided by that mechanism. Yeah, so some key features and use cases. Suppose you want to have high throughput application over there, so which can process millions of messages per second. So we can have Kafka in place. And durability, yeah, the message persist storage for configure periods, like we can have retention policies like that, log retention policy like that for Apache Kafka. It processes the data in real time. Yeah, so it powers event streaming and stream analytics over there. Like you can have the data, you can process the data from partitions, and you can then you will be having the data in consumer application. So after that you can have some connectors over there, like Trino connector, or a Druid you can have, or Spark streaming you can do. So this kind of schematics you can do using Apache Kafka. And there are some use cases, yeah, log aggregation use cases and microservices communication. Like microservices can also use Kafka to have communication, and you can see the practical examples, like chatting applications are over there which are using Kafka for messaging, reading, writing, publishing, and extracting out the messages. In IoT devices, yeah, because in IoT devices a lot of data is there, like there are some sensors over there, and a lot of data is produced per second, you can say. So in that also you can have Kafka in place. financial transactions, yeah, like the applications like phone pay, paytm, there will be a lot of transactions per second. So we have to manage that, so we can use Kafka again. Thank you guys for watching this video, and stay tuned on this channel for more videos.